This meeting is being recorded.
In the next part of this chapter 16 worksheet on acid-base equilibria, we'll take a look at what's referred to as the pH scale. And there's one important equation given here that tells us that this term pH refers to specifically the negative log, now this is a base 10 log, of the hydronium ion concentration. So if you have this value here, the hydrogen ion concentration, or more realistically, the hydronium ion concentration, if you plug this into your calculator, the negative log of that concentration, you return the pH. So an example of this could be if we said pH was equal to the negative log of 1.0 times 10 to the negative 7. And if we did this, plug this into our calculator, we will return this value here. So that's a good number to know, that if you have 1 to the negative 7, this will give us a pH of 7, which is a neutral pH. And we should also note that in pure water, so again, no impurities, we would have our hydronium ion concentration would be equal to hydroxide ion concentration. And these would all be equal to that value, 1 times 10 to the negative 7 molar, right? This is in moles per liter. And we can also kind of find or use the reverse of this pH equation. If we take 10 to the negative pH, that will give us our hydronium ion concentration. And we could do the same thing with POH. So we have 10 to the negative POH, and that will give us our hydroxide ion concentration. So these are all the equations that are good to note for this section of chapter 16. And we also need to be aware of the generalizations that an acid will have a higher concentration of hydronium than pure water. So we'll have a pH of less than 7. So a lower pH than 7 is acidic, and then a basic pH would be greater than 7, and that's because it would have a lower hydroxide ion concentration than pure water. So when we plug that in to our negative log expression, we'll get a pH greater than 7. So in this table over here, we're also given some common reference points as far as hydroxide ion concentration goes, the pH associated with it, and also the pOH associated with that value. And then we would also know, by that extension, the hydroxide ion concentration. So if you know one of these items on this table here, you can solve for the others using the relationships given down here, where pH plus pOH will always give you 14, and the hydroxide ion times the hydronium ion concentrations down here will give you 1 times 10 to the negative 14th. So we may reference this table from time to time in some of the homework questions, but let's take a look here at sample exercise 5 and see if we can solve for the pH of these solutions. So we have a sample of lemon juice, and we're told that the hydrogen ion concentration, so we know that this is really hydronium ion concentration, is 3.8 times 10 to the negative 4th molar. To find pH, remember, we just need to plug in the negative log of that hydronium ion concentration. So we'll do that now. So let's plug into the calculator negative log, and then it should give you a parenthesis, 3.8 times 10 to the negative 4, close parentheses, and then you should get a value of 3.42 for the pH of lemon juice. And a way to approximate your answer is that if you have a coefficient of 1 here, we're going to get exactly whatever this exponent is in the positive form. So if we had 1 times 10 to the negative 4th, we'd have a pH of 4. But since we have a coefficient that's greater than 1 here, we're going to get a pH that's lower than 4. So this is a good approximation. Let's take a look at part B here. So we're asked to find pH, but we're given hydroxide ion concentration. So we're going to have to break this down into a couple steps here. In our first step, we need to solve for our our hydronium ion concentration. And if you recall, we know that 1 times, oh, here it is right up here, 1 times 10 to the negative 14th is equal to our hydroxide times our hydronium ion concentration. So I'm going to rearrange that relationship, and I'm going to have 1 times 10 to the negative 14th divided by, this is going to be my hydroxide ion concentration here. And I'm going to plug in these two values in molar concentrations into my calculator. I'm going to divide 1 to the negative 14th by 1.9 to the negative 6. And I should get 5.3 times 10 to the negative 9 molar. So this is my hydronium ion concentration. So then in step 2, now I can plug in and solve for pH. So that's going to be the negative log of 5.3 times 10 to the negative 9th molar. And that's going to give me a number lower than 9, but in the positive. So I get about 8.28 for my pH here.